Hello, we are Project Phyrctoria. I'm David Sablak.
Ekram Kuzakaya.
I'm Halidos Kaya.
So Project Phyrctoria is a platform that uses Bluetooth signals between mobile devices and tactically placed beacons to more efficiently and precisely detect an infection outbreak through contact tracing.
We use Raspberry Pis as beacons that relay a Bluetooth signal to mobile devices so they can find out their relative position to other devices using their signal strength. And we are running for the overall and specifically for the automation track, which we believe our project falls into.
Thank you.
Okay, so here we have the front page of Project Phyrctoria. The first field that says test is the organization associated, and then your second box here is the email that's associated with your login and also with your organization, and the third box here, the password box, is simply your password. All of this information is pinged to the server so that you can actually log in, and we can test that. Wrong credentials. So when we do log in, we can see this graph here, which basically presents you with all the people that you've been in contact with the past 5 days. The data here is made up, but we do plan to implement this and actually link it with the server. So this report exposure button, when you do press it, this also pings the server and actually lets them know that you were exposed to a certain virus or an infection, and it automatically notifies the other people connected in your network. The notifications is normally supposed to be in the backgrounds, like a background app refresh, but in this case, it gives you your notifications and lets you know if you were in contact with someone that was recently tested positive. But in this case, there are no notifications. And as for the clock in, clock out button, it basically just changes a variable within the system that we plan on uploading to the server so that it can give more accurate information on exactly when you were connected to the beacon and when you left the building or your connection to the beacon.
So we couldn't really finish everything that we wanted to, but here's a demo app that scans for and shows all the IDs of nearby Bluetooth devices. So as you can see, that towards the bottom, three of the bottom four, they start with the ID B8. Those are all the Raspberry Pi beacons, and as you can see, they all have similar relative strength indicators, which signify that the phone, when it was scanning, was close to all of them at the same time.
Hello. All right, so here I'm gonna show just the front end and show that we're not actually doing everything inside the front end. We just have a normal page design with a stack navigator. And here are our pages: login page, sign up page, main page, notification page, report positive page. And for example, the login page uses a button where once it clicks login, takes the inputs from the text fields over here, and then uses Axios to send a post request, and then looks at the response, checks if the credits are valid, etc. We also do this for get notifications. We post to this URL, and if the data is okay, it means you have been infected. This calculation is all done in the back end, whether people have been infected or not. And yeah, not many other parts were implemented. All right, so here we're showing the back end. We have some normal processing of requests here, taking in login information, sign up information. Many of the unimplemented methods in the app were already written in the backend, but we didn't get around to making them. And essentially, the big part is taking in positions of people that are active currently and seeing their beacon strength values as signals. And then we use this algorithm to see if they're near each other. So instead of trying to calculate the distance between people directly, the absolute position of people and then calculating their distance, etc., we use a different approach. If the ratios between the signals among every single beacon were similar enough, then that essentially means that two people are close to each other. So we give this function R near 6 points or 6 signal strengths, let's say, 2 from each beacon to a pair of phones. And then this function standardizes that ratio and then checks that this ratio is close enough within a range. We calculate the distance as 1 over the square root of signal strength and then calculate the ratio like that, since that's a more accurate representation of how signal strengths change over time.